In this particular exercise, we'll be working with a tool and cycle database, which is somewhat incomplete. So we'll be making some tools and cycles on the fly, so to speak. So I'm going to go ahead and get started. So here's the complete file. You can see we've got several processes here. And the process table, 9 processes. We can show the finished part. And we'll segment it. Here's the finished part. So we'll go ahead and get started. Click on the new job button. And we're going to start off with a few things. We're going to open up a tools file, and you'll see here the incomplete tools file. So we're going to open that up, which only has a couple of tools in it, 2 tools. So we'll need to make quite a few tools during this process. And we're also going to open up a cycles file, the incomplete cycles file. And this cycles file, it has a cycle in it, but not one that we can use. So we'll have to build our cycles on the fly. And we'll go ahead and open up a material file. We'll use the free machining stainless. Go ahead and open that up. And then I can import either the DXF or the solid model. We can also draw this part. So I'm going to go ahead and import the solid model. If you don't have the solids, you can go ahead and import the DXF and work off the 2D for this. If you do have the solid model and you've imported it, you'll notice that the part origin orientation is not correct. The Z, the little blue line, needs to be where the X is. So we're going to change the part coordinate system. We've got 4 methods for doing so. So we can use transform coordinate system here or rotate part. So right now we've got the X, Z, and then Y, X, Z, and then Y. And we want the Z pointing out. So I'm going to go from 1 to 3 and click transform. Now you can see we've changed the orientation on this, and I'll click close. We can now set our faceplane, or in this case I'm actually going to extract the turn geometry so you can see me work off the 2D. So here it's extracting the geometry, sectional geometry. We're setting the faceplane and setting the boundaries. So the boundaries are finding the length and OD of the part. So that all looks good. I'll go ahead and click OK. And now we have our 2D. So now that we've got that all set up, I'm going to go to the setup dialog. And we're going to set this to bar stock. Leave the part length, but the OD of the part is set here. We want the OD of the stock, so we're going to use 3.75. A 1/4 inch excess stock. And this is going to be because we're going to drill all the way through the part, and we want to clean up the excess for the next part. So we're putting a 1/4 inch in there, and 3.5 on the work shift, give us an extra 1/2 inch. And we'll call this turn. And click close. So our boundaries look good. Excess stock. So now we can get started programming. You can either program off the 2D or the 3D. I'm going to start off creating a new profile group. And we're going to be turning, but on the face and to the left. I'm going to do this all with a roughing, so we're going to go right to the 0. And we'll get the depth of cut automatically extracted from our tool. We do have a tool for this one in the tool database. So I'm going to call this face. and go ahead and select my tool. Here's a tool in the tool database. I'll select it. You'll see it finds our depth of cut right off that tool, and we'll click close. So there's my profile. I'll go ahead and verify this. I'll show the tool is hollow in 2D and set the verification delay to 3. And there you can see the multiple passes. Okay, so next we got some ID work that we're going to do. I'm going to go ahead and just section this. You can see it a little bit easier. I'll pick a new color, and we're going to do the drilling for this hole here. So I'm going to create a new hole group, and if you don't have the solid model, you're just going to put a diameter of 1 here and leave the nominal depth at the length of the part and click cycle. Since we do, we could extract it right from the model. Say extract and pick the hole here and extract. You'll see it's 1 inch. We're drilling at 1 inch. Now we don't have a cycle, so we're going to add one. And you can see it starts to create our cycle for us. We're going to have a couple operations here. We're going to center drill and then drill. So I'm going to click insert operation one time. So the operation type is going to be center, and we're going to use a drilling cycle. Diameter for my center drill is going to be 0.375. And then drill, we're going to use a pecking cycle, so we use deep hole. Part maker will take care of the depths for us here. Now we're going to go ahead and assign the tool IDs. So we'll click select, and right now it's looking for a center drill, and we don't have one, so we're going to add it. This is going to be carbide tool, and it'll be tool number 2. Rest of the parameters look good here. If you want, we can check the shape out. Looks okay. And I'll say okay. Now it's looking for a drill at 1 inch, and we don't have one. So we'll add that. And this is going to be carbide and tool number 3 with offset 3. Now the length here, we need to make sure this can go all the way through our part. So we'll get a 3.5 inch drill. Diameter at 1 inch. Included angle. The through hole clearance, so it's actually going to go 50 thousandths past the shoulder. And the axial step, so we're going to do pecking, so it automatically assigns half the diameter as the peck depth. So I think that'll work good for here. Shape preview it. Looks good. And say OK. So we've got this cycle all set up now. The drill 1 inch hole cycle, and we'll say OK. If we want to verify the shape, click verify shape. Looks like a through hole to me. You can see part makers assign the depths now. And I'll go ahead and click close. If we want to verify this, you can verify. And you can see it's center drills and then peck drills. Now we've got some ID work to do. So I'll pick another color, and we're going to bore out the remainder of material here. So we'll create another profile group. Turning, this time inside. And again, we'll just go right to finish with the roughing tool. I'll go ahead and select my tool, You can see I don't have one, so I'm going to add a new tool. And here, Part Maker takes care of the orientation for me, so I don't have to change anything there. And this will be a diamond insert carbide. It's going to be tool number 5, offset number 5, and we can assign it to comp number 5. Now the length, we need it long enough to go deep into that bore, so we'll use 3.5 inches. And the width, so this is the back of the tool to the tip of the nose. So this is going to be 3/4 of an inch. The actual holder or shank size will be 5/8. So we can say 5/8. The inscribed circle on the insert, this is going to be 0.475. Included angle we'll leave at 80. The chamfer is just the chamfer on the holder itself. This is going to be 1/8 of an inch. The nose radius is at 1/32, and it's 3 degrees back from 90, so we're going to assign this 93. And I'll leave the depth of cut at 1. We could call this bore bar. Now I'm going to go ahead and click apply. You'll see it calculates all the numbers for me. And we could shape preview this. You'll see it looks good, but it's kind of skinny, so we'll make this look a little more like a boring bar by adding a cylindrical bar to it. So right here is the round shank option. So the shank size and the length. So the length on this I'm going to make at 2.5, and the diameter, I'm just going to use the shank size here, so 5/8. And now we'll shape preview. So you can see it looks a little more like a boring bar. And we'll say OK. Fills out our depth of cut, grabs it right from the tool, and we'll call this ID bore. And click close. Now I'm going to assign this with the define profile. So I'll click define profile and use an end snap. And I'm going to start at the top of this chamfer up here. Click once, come down. Now I want to come all the way back, and you can see I don't have a snap point right here. So I'm going to use a horizontal constraint. Now it snaps me constraining my X value. Come to the back, and then now I can come to the bottom. If we want to verify this, we can verify. You can see, there it is. Makes my boring cycle. Next thing we're going to do is we're going to groove out our thread relief in here. So we'll pick another color and create a new profile group. And this is going to be grooving on the inside. And we're using a rectangle groove, so it's just going to be 4 points. And I'm going to get the depth of cut and axial step right off my tool. So we'll go right to assigning the tool. You can see we don't have a tool here, so it's looking for a groover. We'll make one, so we'll add a new one. Automatically selects our setup for location, orientation, and shank axis. And we'll make a carbide tool, and this is going to be tool number 6. We'll put it in offset 6. And the length on this, 3.5. The width is going to be 3/4 holder. The tip size, so G, which is the width here, this is going to be 1/8 of an inch. The height, so the actual height on this, 1/4 inch height, that'll get all the way to the depth of the groove. And we can put in a chamfer and a nose radius if we like. In this case, I'm going to leave those blank, along with the axial depth and depth of cut. And we'll call this ID groove. So that looks good. We'll say OK. I'll name the cycle and click close. So now for this, I'm going to use the 2-point chain. I'm just going to show this work group only. So you can use the 2-point chain, or on the solid, the chain geometry. So with a 2-point chain, you want to make sure that you're on towards the top side here. So you want the point to be in the corner, but you want to be above it. If you're over here, the chain's going to head around the wrong direction. So make sure your mouse is up above a little bit to the left and click. Now you can see it'll chain in this direction. So you can come to this point here and click again, and the chain's complete. And we'll go ahead and verify. Let's zoom in on that. Now you can see we're actually moving in and rapiding up against this wall. So to avoid that, we'll go back into our ID groove and our clearance value. We'll make this a bit bigger. We'll make this 1/4 inch and click close. If you need any values off of any of these things, you can always double click on a surface and find out the height or the radius. You can also go in the CAD and double click on any of these lines here, get a line length, gives you some information. So let's go ahead and verify that again now that we've made this change. So that looks a little bit better. You can see it pecks into the hole. Okay. Click Show All. So the last thing we have to do is our threading. So I'm going to pick another color here, create a new profile group, and this time we're going to be threading. On the inside, with no chamfer because we've got a thread relief, my first infeed, we've got this at 15 thousandths. So I'm going to change that. We'll make it 10 thou. My minimal infeed is 1 thou. So this is going to work for our constant volume algorithm to remove material, getting less deep per pass, keep the load on the tool consistent. And the rest of these we can actually automatically set just by entering some parameters on the tool, such as the thread per inch to calculate the pitch, the tool angle to get the infeed angle, and thread height will calculate automatically. So let's go ahead and see if we have a tool. We don't have a threading tool, so we'll add one. And this is going to be carbide. This will be tool number 7 and offset number 7. And the length on this tool, make it 3.5. That's going to be 0.817. The tip size, we're going to make that 1/8 of an inch. And the actual height, we're going to make that 200 thousandths. It's a 60-degree tool. We'll say 0.1. And the threads per inch, if you look back at the drawing, is actually the default value here, 10. So plug that in if need be. And we'll call this ID threader. Check the shape preview. Looks good. And we'll say OK. I'm going to call this ID thread. Now one important thing to do here is make the acceleration distance bigger. You usually like this to be 2 or 3 pitches. So you can see we've got a 0.1 pitch. So I'm going to make this 1/4 inch. This will allow the spindle enough time to get up to speed as the tool begins accelerating towards the part. So we'll go ahead and click close. Now I'm going to define my profile here and snap. And I'm going to start here, and we want to go past this corner into the thread relief. So I'm going to use a horizontal constraint with a mid snap. This will allow me to go halfway into the thread relief. So we're just basically finding the mid snap of this line here and click. And I'll go ahead and verify. So you can see there's our multi-pass threading. So next we're going to do the OD of the part. Pick another color here. Create a new profile group. This time turning out and to the right. I'm going to leave some material on here for a finish pass. We'll say 30 thousandths on the X and the Z. And I'll get the depth of cut off my tool. We'll also say roughing tool and finishing tool, so you can plug in the surface roughness here. So this will affect the feed rate on the finishing cut. So if you look at the print, this is actually 32 micron finish. And we'll go ahead and select the tool. We don't have a turning tool for this, so we'll go ahead and add one. So this tool is going to be diamond carbide. It's going to be tool number 4 and offset number 4. Comp number 4. Length on this tool is going to be 1.5 inches. The width, the back to the front, is going to be 1.25. The shank size, 1-inch shank or holder. Inscribed circle on the carbide insert is 3/4. The included angle is 55 with no chamfer, with a 1/32 insert nose radius, and it can be a 94 degree, this edge angle back here, so 4 degrees from being vertical. And I'll leave the depth of cut at 0.1. I'm going to call this OD turn 55 DEG for a degree and 0.03 R for the 30 thousandths radius. Click apply, you can see it all calculates out, and click shape preview. So you want to make sure here you get an insert and a holder. If you try experimenting with some of the other values and you don't get the holder, then you've got to change something. I'll give you, for instance, let's make the length here 1. Click shape preview. You see I get just an insert. So this means something's wrong. Here you can try verify shape, and you can see it actually shows you in the 2D preview the insert's bigger than the length of the holder here. So if we make this back 1.5, now you can see this looks a little bit better. Now we get the holder. So we'll say OK. It's prompted me now for the finishing tool. We're going to use this same tool we just created for the finishing and the roughing, so we'll select it. So it's assigned that tool to both of these. And we'll call this OD turn and click close. So now to go through here, you can either use the define profile or the 2-point chain, either will work. I'm going to use the 2-point chain. So we'll start here, making sure I'm on the left side of the point. Okay, if you go down here, it could go the wrong way around when it does the chain. So start on the end, be on the left side, click one time, and you can just drag your cursor right to the end and click again, and there's our chain. Go ahead and verify, say OK. Now I'm going to put a little lead out on our finish cut. You can see here's our boundaries. So we're actually wrapping out of the stock back here. And you'll notice too, I didn't get any cutting limit errors. If I show my cutting limits, you can see we intersect at this point here and this point here, so it knows it has to clear out all this area. So I'm going to go back in here and just change my lead out. Make it 100 thousandths at 45 degrees. I'm going to verify this again. Maybe a little bit longer. $150. That looks good. Okay, so the last thing that we have here is our cutoff. So I'm going to go into my extended palette. We'll pick another color and create the cutoff. So I'll choose a cutoff cycle. And we don't have a chamfer or anything to insert, just a straight plunge. We'll select a tool. We actually have a cutoff tool here, so I'll select it. Call this cutoff. And everything's already set for me. It knows the start point based on my stock diameter, and knows the cutoff distance based on my part length. There you go, does the cutoff, and we can verify it. Looks good. So we've completely programmed this part. Now we can generate the process table. So here's the process table. If you want to change any of the parameters here, you can. Feeds or speeds. You can turn comp on, change tool numbers. You can also turn on and off constant surface speed here. Or if you want canned output, you can change that along with coolant settings. Also, if you want to reorder any of these, you can. Everything looks good, so I'll go in the simulation. Here I've got some transparent stock. So if I go in my simulation options, you'll see the transparency stock's at 30. And my time delay is set to 1. So we'll say OK. And I'll click play. And show finished part. If you want to slice it. Looks pretty good. So I already have a post selected here. If not, you can go in and select your post from the post lib folder and generate your G code. Put in your program number, block start, block increment, say OK, and I'll just save this off to my desktop. I'll call it test. Click save, and there's my code. If you want to edit the program, click edit program, and here it is in my notepad editor. So now you can load it on the machine.